Hi everybody, in this video I will explain to you how you can use the ANOVA technique to measure the difference between the means of observation, difference of means between different groups. Here we have assumed a data. This data set shows about the means, about the observations of three different variables, the three different groups. For example, a group of customer was given tea, a group of customer was given coffee, a group of consumers was given a juice. So three group of consumers, they have shown their level of satisfaction. This score is showing their level of satisfaction. Now our objective is to test the hypothesis. What is the hypothesis? H naught, basically assumes that there is no significant difference between the means, which means that mu1 is equal to mu2 is equal to mu3. That's mean mean of tea consumer, coffee consumer and juice consumer is equal. So we write here there is no significant difference. Significant difference between in the mean between means. Consumer satisfaction. You can use the shortcuts. You can write mu1 is equal to mu2 is equal to mu3 like that. Okay, that is also very convenient way to write it. Second, we write alternate hypothesis. Alternate hypothesis will be opposite of this hypothesis. This hypothesis says there is no difference, no significant difference. So H naught will say that there is significant difference, just omit the no, or at least one mean is different, or you can say that mu1 is not equal to mu2 is not equal to mu3. So one is different. So in this way you establish this. Next is your confidence interval, that is 95%. We assume when this is 95%, then what will be the level of significance? Alpha. For alpha, let's insert alpha. So we go for here Greek Coptic. This is alpha, insert. Okay, alpha. Alpha is equal to 1 minus confidence interval CI. Sorry, here I will be capital. So C 1 minus 95%. This means that 1 minus 0.95, and that will be 0.05. This is your confidence level. So now we are interested to know that how we can compute. In manual computation, there is a process of computation and you will fill the ANOVA table. But here in Excel, using automatic tools of data package, it will come automatically. How it comes? Before you use Excel for any kind of analysis, statistical analysis, be sure that you have uploaded data package. Here you will find one button, that is option. Go to option. Option is on the left down. When you click on file, again I am telling you, when you click on file, so here one will come, that is option. It is hiding here, but here is one option. When you click on option, go to adds in, go and analysis toolbar, check this box and okay. So already this is there. So now I am going to apply this tool. Click on the data. When you click on data, you will see here analysis tools. In the analysis tools, I need ANOVA, ANOVA single factor. Okay, click on this. Now different dialog box or windows are opening. Input range. This is asking about our data. Input range will be our entire data. We have put the data into this. As you see that we have taken the labels. So check into the labels. Alpha is 0.05 already by default. So next is where we want our output. Our output can be in new worksheet, in new workbook, but we want it here. Click inside. It is very important to click inside first. Okay, then you go and select the place where you want your analysis to be shown. Just click on OK. So you will get this data. So there are many digits after the decimal. So let's click the number. So it will be just 2 points after the decimal. So in this, you can see that, oops, it has gone too much. So this is your ANOVA table. What in manual computation you use to make it. What is important in this? This is sum of squares between the group. Okay, this is sum of squares within the group. This is degree of freedom. We have 1, 2, 3 groups. 3 minus 1, 2. This is 54. Degree of freedom within groups. Within groups mean all together are 56. And 56 minus 2, 54. Mean square, you know, this is obtained by dividing sum of squares by degree of freedom, 4.28. Sum of squares within the group, this divided by degree of freedom, 54, 0.47. When you now you are going to compute F ratio. For F ratio, you know the principle when you are calculating manually. So this is this divided by this. In a mean square between the group divided mean square within the group, and this is the p-value. P-value is actually the probability of rejecting null hypothesis. How much are the chances that our null hypothesis will be rejected? This is critical value of of F. So critical value you get by using F table. So 2 on horizontal, on vertical 54. So value of 2 against 54, what will be the value? That is 3.17. Manually we use the table. So now here is the rule. Rule says that you can see that critical F tabulated is more than F critical value. This means this is outside. So P is less than 0.05. Here is the cutoff rule that if P is equal or less than 0.05, then we reject null hypothesis. If it is greater than 0.05, we accept null hypothesis. So in this case, this is less than 0.05. So what we are doing, we reject null hypothesis and we accept the alternate hypothesis. So what will be your conclusion? When you write the conclusion, there is a rule. The rule says that F bracket, here you will use degree of freedom at 2,54 is equal to, what is that? 9.05. 9.05 and comma again, and P equal to 0.00. Okay, after writing this, what you do, you write that H naught, null hypothesis, is rejected. When we reject the null hypothesis, so what it means, null hypothesis was saying that there is no significant difference between the means. When we reject this, this means we accept this. When we accept this, we are accepting this assumption or this statement. So the same statement you write here and you just paste here. So this is your conclusion. In your answer, you have to display these values only. Okay. In your answer, what you do, you display this table and these values. So in this way, you can compute analysis of variance by using statistical analysis tools available in X. So these values you can report anywhere as an answer. This is your answer. Remember, P value is used as a parameter. Its cutoff value is the rule. If it is equal or less than 0.05, reject null hypothesis and accept alternate. If it is more than 0.05, then you will accept null hypothesis and reject alternate. So hopefully this will benefit you. Thank you very much.